Okay, so playing with these traps from SOTABeam for 14 megahertz, the 20-meter traps. These went together pretty well. I'm trying to experiment with self-amalgamating tape to try to act as a binding or turns fixer. If you wrap them completely, you change the dielectric constant, the permittivity, and you detune them. Basically, the frequency goes down. So I'm thinking of putting these in a PVC piping or something, and then weather sealing the piping. But these are tuned to 14 megahertz on this setup with a frequency generator, and then peaking the relative energy in the traps, so that the 14 megs are good. That's on the 14 megahertz. This one is a 10.1 meg for the 30-meter band, which I didn't realize until this morning, just how, where is it, 30 meters, how narrow that band is. It's only 50 kilohertz. Good God. And that's the challenge, because these, when you put in the value of the capacitor and you wrap it with the number of turns, if you put if it's too many turns, you're like 300 kilohertz away, and if it's too few turns, then it's 300 kilohertz the other way. So you got to get close, and you can then control the peaking by spacing the wires on the toroid. This one, you can see, got a bit of space at the bottom. I managed to get it peaking 10.1. Happy days. This one, however, proved problematic. Even with full spacing, I couldn't quite get it to peak at 10.1. It was peaking at 10.04 megahertz, which is 60 kilohertz away from the bottom of the band, but the band is only 50 kilohertz itself. So it's these are a bit tricky to peak. So basically that means the function of whatever capacitance you have, what's going on in this particular example of a toroid, and so on, to kind of find the right ballpark. But I was frustrated that I couldn't move these wires to get it to peak at the right place. So I went back to the drawing board, and if you do the mathematics, recalculated what I would need to get a peak at 10.1 megahertz. I need to add a 3.4 nanofarads in series with the existing 100 puff cap. This is nominally 100 puff. I think it tested at 101. It's a 1,000 volt cap, which I guess depends. They don't know what you're going to put across this and where you're going to put it. So the voltage max could be 1,000 volts. Fine. I found a capacitor in my junk drawer of 472, which tested, that's nominally 47 or 4.7 nanofarads, tested at 3.8, close enough. Put it in series. Now this is a 1,000 volt capacitor. This is probably good for 16 volts or something, or 25 volts. But it turns out that when you put capacitors in series, the resulting capacitance, which is the 1 over law, 1 over total cap is 1 over this one plus 1 over that one. The voltage distribution across these two capacitors in series is also high voltage across the small cap and a low voltage across the large cap, which is perfect. So I think I might get only about 5 or 10 volts across this one in worst case conditions. So anyway, change the capacitance and I can peak it again. So 10.1, it was peaking down here somewhere. You can see it's much smaller. I just couldn't get it to peak any higher, but now it goes all the way up to, well, to about there, which is 10.1. Very happy with that. The final tweaking of the wires let me narrow it down to 10.1. So I'm going to try and wrap it with some tape and then try and figure out how to seal these things. And the 1-to-1 balun at the center of the dipole has arrived in the post. I just missed the post guy, so I got to go pick it up. But there you go. Having fun this morning, peaking my traps.